Go is an amazing language, but if you're coming from older programming languages like C, Java, or Python, there might be some features of Go that are odd. So here are 6 tips for beginners in Go. Zero values. Zero value in Go is like a default value for a variable. A zero value depends on the variable's type. In this table, we can see the zero values for some of Go's types. As you can see, strings, booleans, and integers are given real values, whereas more complex types, like pointers and slices, default to nil. In this example, we have 3 variables: name, age, and address. Since we haven't given any of the variables values, they will be using their zero values. Name will be set to an empty string, age will be set to 0, and address will be set to nil. Type inference. Type inference lets us infer the type of a variable from the value provided. Thanks to type inference, we only need to state a type or a value when creating variables. To use type inference, use a colon and an equal sign to create a variable and infer its type from the value given. In this example, we're creating a string variable and setting it equal to example. This requires quite a bit of writing, since we have to write the var keyword, the name of the variable, the variable's type, and the value of the variable. But thanks to type inference, we can remove most of this. With type inference, we just need to state the name of the variable and use the type inference symbol and give the value. Doing this tells Go to create a variable called example, infer its type from the value it's given, and then set it equal to this value. You might think using the var keyword and stating a variable's type isn't that much extra writing, but imagine you had to create a map with a string key and a string value. To do this in Go, without type inference, you would have to use the var keyword, state the name of the variable, and state its type to be a map with a string key and a string value. You would then have to set it equal to an empty map to initialize it. But with type inference, we just need to state the variable's name and set it equal to an empty map. This tells Go that the variable we are creating is a map. Type inference can also be used with the values returned by functions. Here, we have a function called sayHello that returns a string. We want to set a variable equal to the value returned when we call this function. We create a variable hello, and using type inference, we can set hello equal to the value returned by the sayHello function. Multiple returns. In Go, we are allowed to return multiple values from a function. When a function returns values we don't need, we can ignore it by assigning it to an underscore. Multiple returns are often used to return errors from functions. This feature often leads to patterns that are very different to other programming languages like Java or Python. Because most functions will return an error, it means we have to do a lot more error handling when we're writing Go code. But this often means we can handle errors gracefully and avoid runtime errors. Here, we are using a function that returns 3 different values: a string, an integer, and a boolean. If we want to use all 3 values that are returned by the function, we can use type inference and create 3 variables to hold each of the values. If we are only interested in 1 or 2 of the values, we can use underscores to ignore the values we don't want. In this case, we are only interested in the boolean value, so the string and integer values get assigned to an underscore and are ignored. In this example, we're using the read file function from the OS package. The function reads the contents of a file, and it returns an error. If the error is not nil, it means that there was an error while reading the file. This is an example of how multiple returns can be used for error handling. If the function does not encounter an error while reading the file, the error will be nil. But if it did, we can handle the error gracefully. Inline variables. Inline variables are a special syntax in Go that allows you to create a variable and use it in an if statement, all in the same line. This is usually used to check errors from a function and then handle that error if it exists. This simple example shows the syntax for inline variables. We create a variable after the if keyword, and then we use that variable in the if statement. If the condition is true, we enter the if statement. In the example, we are creating a variable x and setting it equal to 10. We are then checking if x is greater than 20, and if it is, we will enter the if statement. Since we are setting x to be a set value, this if statement will never execute. That's why this pattern is usually used when calling functions. This example shows a more realistic use of inline variables. In the example, we're going to marshal a variable into JSON, and we want to check if there's an error during marshalling. We don't care about the value returned, so we can use an inline variable and check if there's an error while marshalling. If there is, we can handle the error. Using inline variables helps save us a few lines when we're calling functions and we only care about the error that is returned. Public variables. Go does public variables a little differently to most languages. In languages like Java, we have access modifiers like public, private, and protected. In languages like JavaScript, we export variables and functions that we want to use outside of the file. But in Go, there's only two access modifiers, public and private. Unlike most languages, variables are not made public using keywords. To make a variable public, the variable name must start with a capital letter. Once a variable's name starts with a capital letter, it is now accessible outside of the package. Private variables are scoped to the package, and only public variables are accessible outside of the package. Here we have two variables, name and age. Since name starts with a lowercase letter, the name variable is a private variable. It is only accessible within the utils package. But the variable age starts with an uppercase letter, so it is a public variable accessible outside of the utils package. Functions in Go are also variables. So to make a function public, we do the same thing as we would with any variable. Here, we have two functions, say hello and say bye. The first function, say hello, starts with a lowercase letter, so it is a private function. The second function, say bye, starts with an uppercase letter, and so it is a public function. Pointers. A pointer is a variable that stores the memory address of another variable. Pointers are not unique to Go, but pointers in Go work differently to some languages like C. Go does not allow pointer arithmetic. Pointer arithmetic is the use of math on a pointer to change the memory address that it points to. Here I've created two variables. One is a string and the other is a pointer. The pointer points to the memory address of the first variable, example. When we print the two variables, we can see the different values that are stored by each. When we print the variable example, it prints example, which is the value of the variable. When we print the pointer, it prints a memory address. This is the memory address that stores the first variable. In the final print statement, we are dereferencing the pointer. This means that we are getting the value that the pointer is pointing to, and so it prints the string example.